In this video, I introduce a model compression for knowledge distillation. Ensemble is a collection of models whose predictions are combined by weighted averaging or voting. Model compression method compresses the function learned by a large model into a much smaller model with a comparable performance. Instead of training a small neural network on the original training dataset that is used to train the ensemble of large network models. The model compression method uses the ensemble of large network models to label a large unlabeled dataset and then trains the small neural network on this much larger ensemble labeled dataset. The small network trained on the ensemble labeled dataset has a better performance than on the original dataset. This is a training dataset that is used to train models through ensemble selection to get ensemble models. Based on this training dataset, we generate a large pseudo dataset, and then this ensemble used to label the large pseudo dataset, and then we use it to train a small model, and finally deploy the model on the mobile platforms. Monge generates a large pseudo dataset, which is then labeled by ensemble selection and used to train the compressed neural network. The dataset generated by Monge through a non-parametric estimate has a full joint distribution of attributes with the original dataset. Starting from the original training dataset, Monge visits each example once and determines his closest neighbor by using Euclidean distance for continuous attributes and Hamming distance for nominal attributes. Knowledge distillation is realized through pseudo dataset labeled by ensemble models to train the compressed models. The ensemble models generated by the ensemble selection through voting can achieve the better performance. The compressed model has a closer performance to the ensemble as the Monge data increases, as shown here. For more details, please check with these references. Thank you. Bye.